The dust settled billions of years ago. Our cities, our clouds, our very planet, all are gone. Yet, in the silent vacuum of time, a single etched glass disk remains. It holds everything. The entire human genome, our great books, the maps of our rise and fall. But who will find it? And when they do, will they even know how to read the ghost of a lost world? This isn't science fiction. This is the story of a real technology designed to outlast humanity itself. A memory card built to survive for 13.8 billion years. The question is, what message did we decide to send to the end of time? And what if the beings who find it aren't our descendants, but our replacements? In the early 21st century, our digital world was built on a foundation of sand. We were creating information at an explosive rate, capturing every moment, every discovery, every thought. But the tools we used to store it were fragile. Hard drives would fail after a decade. CDs would scratch and degrade. Even the mighty cloud servers, these massive data centers humming with electricity, were predicted to crumble within a century. Data rot, bit decay, hardware failure. These were the silent enemies erasing our history as fast as we could write it. Humanity was generating a digital legacy that was destined to vanish. A library of Alexandria burning down in slow motion all around us. Every great civilization before us faced the same relentless enemy: time. And it was a problem that conventional science, obsessed with the fleeting world of zeros and ones, simply could not solve. We were on the verge of becoming a lost civilization, with no record left to prove we were ever here. The breakthrough didn't come from Silicon Valley. It came from a lab at the University of Southampton in the United Kingdom, around 2013. A team of scientists, led by Professor Peter Kazansky, decided to look beyond the fragile world of electronics. They turned their attention not to silicon, but to quartz, one of the most stable and abundant minerals on Earth. Their idea was revolutionary. Instead of encoding information on a surface, they would write it inside the very structure of the glass itself. Using incredibly precise and powerful femtosecond lasers, lasers that fire pulses lasting just a few quadrillionths of a second, they began to carve information into 5 dimensions. 3 of these were the familiar spatial coordinates, the length, width, and depth inside the quartz. But the other 2 were far more ingenious. They also controlled the size and the orientation of the tiny nanostructures they were creating. This multi-dimensional approach was the key to unlocking a density and permanence of data storage that was previously unimaginable. This wasn't just another hard drive. This was the first key to eternity. The result of this 5-dimensional data storage was staggering. A tiny disk of fused quartz, smaller than a coin, could now hold 360 terabytes of data. To put that in perspective, that's equivalent to about 100 million photos, or the entire content of a massive library, all stored on something you could easily hold in the palm of your hand. But storage capacity was only half the battle. The true revolution was its permanence. The material they used, fused quartz, is incredibly resilient. It's chemically inert and thermally stable, meaning it could withstand temperatures up to 1000 degrees Celsius without losing a single bit of information. The team subjected these disks to extreme durability tests, boiling them, baking them, and simulating the passage of millennia. Their projections showed a revolutionary, almost unthinkable lifespan: 13.8 billion years. That is the current estimated age of the universe. This disk wouldn't just outlast a human lifetime, it would outlast the Earth itself. It could survive the death of our sun. It wasn't merely data anymore, it was humanity's eternal, uncorrupted memory. The scientists nicknamed it the Superman Memory Crystal, a nod to the crystals in the Fortress of Solitude. They had created the memory of a god. With a technology capable of preserving information for billions of years, a profound question arose. What should be the first message we send to the far future? What information is so vital that it deserves to be immortalized? The answer was almost immediate and unanimous: the entire human genome. Our most fundamental blueprint, the 3 billion letter code that defines our species, was chosen as the first great payload. It was our scientific and biological soul, preserved not just for centuries, but for geological epochs. They called this mission Eternal Storage. The disk became the ultimate time capsule, a scientific Noah's Ark floating on the river of cosmic time. The logic was simple and profound. It ensured that even if our civilization was reduced to ash, even if every city crumbled, and every book turned to dust, the instruction manual for creating complex life, for creating us, would endure. It was a message of hope, a seed of our existence planted in the soil of deep time, waiting for a future mind to discover the recipe for humanity. But what good is an immortal message if it's lost in space or if no one can find it or understand it? Preserving the data was only part of the problem. Ensuring its discovery and decryption was the next great challenge. The decision was made to place one of the first copies in a secure, geologically stable location, far from the chaotic surface of the Earth. The chosen site was a centuries-old salt mine in Hallstatt, Austria, one of the oldest in the world. Buried deep underground, the disk would be safe from the sun's radiation, the wind, the rain, and the slow, grinding erosion of time. It would rest in silent darkness, waiting. Now, the final, chilling question remains. The data is safe. A key to reading it, a microscopic Rosetta Stone using universal mathematical and physical symbols, is inscribed on the disk's surface. But what if the next intelligence to find it, millions of years from now, is not human? What if they use our genome not to understand or restore us, but to replace us? Have we just sent a letter to the future, or have we buried a weapon? The answer lies waiting, deep beneath a mountain, for a future we can't possibly imagine. Thank you for watching. If you're fascinated by the technologies shaping our future and our past, make sure to subscribe for more deep dives.